you get approximately 18.3736. All right, let's take a look at the next page. So I'm actually going to start down here with the one on the bottom. So, and then we'll come back to C and D. So as we look at E, I would start off and we want to combine the left side to make one log. So log base 2. And if we're adding, we're actually going to multiply these two things. So of x minus 1 times x minus 3, and it all equals 3. Now you can use your definition of log, like log base 2 raised to the third equals your answer, right? Kind of think about that E thing. So 2 to the third equals x minus 1 times x minus 3. So 2 to the third is 8, and if we multiply this out, x times x is x squared, x times negative 3 is negative 3x, negative 1 times x is negative 1x, negative 1 times 3 is a positive 3. So we get 8 equals x squared minus 4x plus 3. We want to set it equal to 0, so we're going to subtract 8. We get 0 equals x squared minus 4x minus 5. So now we're to factoring. We've got x minus 5, x plus 1, so x equals a positive 5 and a negative 1. So now, the one thing you got to remember is to go back and just double check. As you plug those values in, what our inputs into the log are, they have to be positive, because remember our domain is from 0 to infinity. So 5 minus 1 or 5 minus 3 is okay, but negative 1 minus 1 is a negative. The input must be positive. And you really have to go back and plug it in, because it is possible that when you multiply it by something in that equation, that a negative times a negative ends up being a positive, but here the only answer is x equals 5. Okay, let's look at the next one in a similar manner. So this time we're subtracting though. So we're going to want to go ahead and divide. We've got, so log base 4 of 4x divided by x divided by 4 equals 3. So think about 4x divided by x divided by 4. I'll probably just simplify that and think that's 4x multiplied by the reciprocal, so 4 over x. Your x's cancel, so we get 16. So log base 4 of 16 equals 3. So we use our definition, we got 4 to the third equals 16. Is that a true statement? Well, it's not. That is not true. So therefore, how many solutions do you think there are? There is no solution. All right. As you go back, I want you to try D on your own, and if you do it correctly, you should get x equals 4/3. So pause the video and try that. And then when you're all done, I'm going to go easy on you. With this whole online learning thing, I realize things are a little bit difficult, so I'm going to take off C, and then I'm going to say on your homework, you can skip number 13 if you have watched this video, and I will go ahead and remove it from the homework. All right, now for expanding or rewriting logarithms. So whenever we expand, we want everything in terms of like addition and subtraction, and we want like no exponents. So let's try that. So here we are multiplying two things. So our log rule is if we're multiplying by that, we can go ahead and add natural log of x to the third plus natural log of y squared. And we don't want any exponents, so we're going to go ahead and bring these out front. So we'll have 3 natural log of x plus 2 natural log of y, and we have expanded it all the way it goes. All right, looking at this next one, we're dividing. So we're going to go ahead and divide. So our exponent rule of dividing is subtracting. So we're going to do log base 2 of 128 minus log base 2 of x squared plus 4. Okay, you're going to be tempted to see that plus and be like, okay, hey, I'm going to multiply now. But be aware here, notice it's like over on the left, you have to be adding 2 logs and we can make it multiplying. It's not that you can have a log of 2 numbers being added that then changes to multiply. So that actually is the simplest form. Or if you wanted to evaluate this first one, 2 to the 7th is 128. So log base 2 of 128 is 7. And then I could rewrite this log base 2 of x squared plus 4. And that would be the simplest form. Okay, let's do D together. I'm going to have you come back. Actually, let's do C together, and then I'll have you try D. So on C, I'm going to rewrite this real quick and say, hey, this is natural log of z to the half divided by x and y. So there's two ways you could think about it. You could say, okay, well, that's natural log of z to the 1/2, and then I'm subtracting natural log of x times y. That's what I'm dividing by. So if I wanted to break this apart, you would think about, hey, that's natural log of x and that's natural log of y, and you'd think that it's adding. But notice here we're actually subtracting both of those things, so really that'd be in parentheses, and that subtraction would distribute out. Another way to think about it is, since these are both on the denominator here, like the x and the y, ooh, that's kind of funky, then we are subtracting both of them such that we divide by it. Okay, so I still got natural log of z to the 1/2 out front, so if I want to get rid of that exponent, I put out front, I get 1/2 natural log of z. Okay, I want you to try this next one. I'll give you a hint. I probably would start by rewriting it as log of 10 x to the 2/3 over y. And if you've done it correctly, when you expand it all, I simplified log base 10 of 10 to be 1, but this may also be in yours, log base 10 of 10, plus 2/3 of x, 2/3 of log of x minus log of y. Okay, on these other ones, when it says to condense it or express it as a single logarithm, we want everything to be like times, divide, and have like exponents. So let's see. Let's rewrite each term at a time. So let's get rid of the numbers out front. Those are our exponents. So we're saying that's really natural log of x squared plus natural log of y squared minus natural log of z to the 4th. And then this will be natural log. The addition will be timesing, so x squared, y squared. The subtraction would be dividing by z to the 4th. I put in parentheses just so we know that's all the natural log of that single number, but we've got it. Okay, you try this next one, and if you've done it correctly, you should get log of 6x to the 9th. See what you come up with.